In this video, I'll describe the issue with my OM System 150 to 400 mm lens, and I'll go over a few examples to help illustrate the issue. Before we jump into the examples, I'd like to briefly explain the problem with my lens. Normally, the sharpest part of a lens is in the center, and as you move further away from the center, the sharpness naturally declines. The center of the frame is typically the sharpest, and some performance may drop off at mid-frame, and furthermore in the corners. This is normal and expected. The problem with my lens is that the sharpness is shifted towards the bottom right quadrant of the frame. As a result, the top left quadrant of the frame suffers. This suggests that one or more elements within the lens is either decentered, tilted, or both. As we go over these examples and comparisons, please understand that the issue is not that the 150 to 400 mm lens is softer than my Olympus lenses, but rather, the elements inside the lens are misaligned, causing a quarter of the frame to be abnormally soft. This is my first time buying an OM System branded lens. As you'll see in the comparisons, my Olympus branded Pro lenses do not have this issue. They were properly calibrated at the factory to prevent such shortcomings. A Pro Series lens should not have such defects, especially a flagship lens at this price point. With that out of the way, let's jump into the examples. Here is a test shot that I've set up with the lens at 400 mm. This is the same shot included in the files I've shared on WeTransfer. If we take a look at the upper left corner, this is what that looks like. Note how soft and blurry the hash marks are within this area. The ribbon pattern in this area is also very fuzzy and lacks contrast. Now let's compare that to the bottom right corner. The hash marks here are much more well defined, and the ribbons are also much sharper. When we go back to the top left corner again, we can see a distinct drop in optical performance. Here, we can see the comparative sharpness between all four corners. Not only is the top left corner particularly soft, but we can see that the top corners perform worse than the bottom corners. This will be a recurring theme as we go over more examples. Next, let's compare the mid-frame performance between the top left quadrant and the bottom right quadrant of the frame. First, let's take a look at the bottom right quadrant's mid-frame. Again, the bottom right quadrant shows well-defined details with good contrast. Each line is sharp and clear. There are no fuzzy or soft edges. This is how a Pro lens should perform. When we take a look at the same test shot that I took with my Olympus 300 mm f4 Pro, we can see the same sharp and well-defined lines within the mid-frame. If we take a look at the top left quadrant's mid-frame of the 300 mm lens, we can see the same sharp results. This lens is properly aligned. However, if we move on to the problematic quadrant of the 150 to 400 mm lens, the results are disastrous. The edges of the lines are not well defined at all, and there's an obvious layer of blur across the frame. Keep in mind, this is no longer showing the extreme corner. This is the mid-frame region, where it is critical for a lens to produce sharp results, as this is exactly where the rule of thirds lie. The composition of many wildlife shots will often have the most important part of the subject in this region, so it is paramount that the lens delivers here. When we switch back to the bottom right quadrant, we can see a stark difference in optical performance. This difference should not exist in a properly aligned lens. This difference does not exist in my Olympus 300 mm lens, nor does it exist in my Olympus 40 to 150 mm lens. If the decentering only affected the extreme corners of the frame, then it would be less problematic. However, the decentering of the lens is so significant that it affects the composition well within the mid-frame. The softness intrudes into the mid-frame, where I will often compose for the subject's eyes. As you can see in these examples, the texture and pattern in the wood is consistently softer in the top left quadrant of the frame. The top half of the frame is also consistently softer than the bottom half. Here, I have highlighted the affected region of the midframe, where we see a distinct drop in optical performance. With this overlay, I'll briefly cycle over some of the shots I've taken in the past 12 months with my Olympus 300mm lens. These are uncropped photos. Notice where the subject is composed within the frame. In wildlife photography, the subject's eyes are usually composed within the top half of the frame. And when the subject is not framed in the center, it's often framed within the mid-frame at the rule of 2/3. It should be clear now why this is so problematic. The defect in my lens affects the most critical regions of the image in a negative way. Had the decentering been reversed, with the softer quadrant at the bottom, this would have been less problematic. I would still be very dissatisfied with such a result, but at least the lens would be more usable. But in the current state of my lens, I would have to shoot with my camera upside down in order to avoid the softness impacting my photos in critical regions. But surely, a longtime customer and supporter of the brand should not have to resort to such measures when using a $10,000 flagship product. Thank you for watching and taking this matter seriously. I hope OM Systems will demonstrate a commitment to support its customers in the same way that Olympus has.